This is a schematic of the patented Williams Innovative Sludge Treatment System, which basically consists of several components. Basically, there's a grinding circuit, a combustion circuit, and then basically a cleanup of the gases produced during the combustion and drying, and the exhaust to the atmosphere. Now we can flip the page and come over here and just look at the grinding circuit separate, where we bring in the wet sludge into an impact mill, a fluidized bed impact mill, which basically does two things. It does a pre-grind of the material. It also brings hot gas to support the fluidized bed to dry this wet sludge coming into the system. So coming out the top as a function of the terminal velocities of the particles we produce, we take off the size particles due to this terminal velocity with the moisture and the recycled gas that we produced in the mill. The drying process, in other words, produces moisture. That's all carried over and taken to a cyclone where we separate the solids and the gas. The gas goes this way. Of course, the solids go down and go into what we call a meteor mill, which is a screened impact mill, which does further sizing, and it actually produces the size particle we want for the combustion process. So now we've got, coming out of here, we've got the size combustion particles coming out of this system. Basically, we've got the recycled gas, the gas that we produced in the drying mill over here. We want to treat both of those in the combustion. Now we can go to the next page, and this shows in the combination of the grinding circuit along with the combustion cleanup circuit. Here's the combustor, here's the SDF combustor. We bring into the combustor the gases that we've driven off in the drying process, the grinding process. We also bring in the dry sized sludge particles for our combustion. Now this is also supported with natural gas, such that we can operate the combustor at basically 17 to 1800 degrees with a 2-second residence time. So here we combust the dried particles that we produced over here. We also bring in the gas and the water that we produced in the drying process. We run them through this 1800 degree furnace. We sanitize the total product, plus we produce an ash product here, a sanitized product here, at basically about 1500 degrees Fahrenheit. Part of that gas is taken over to run the drying circuit. The other part of the gas is brought up to a primary heat exchanger, where we take off the hot gases to save energy and to supply air to the combustion process. But that's still not cool enough. We have to have another heat exchanger where we just bring in fresh air, cool the gas such that we can meet the temperature limitations of the baghouse. Basically about 350 degrees Fahrenheit. So the secondary heat exchanger does nothing other than just to cool the gas to meet the requirements of the baghouse. This is a place that we can take a look at in the future, and because we're throwing away an awful lot of energy right here, and we could actually produce some power there. But anyhow, the cooling gas is sent to the stack, as well as the gas that passes through the baghouse and enters the stack as well. So this cooling gas basically dilutes the stack. Here's the exhaust from the system. Down at the bottom then of the combustor, coming back to the combustor, we bring the ash off. We also bring the ash off the baghouse. We transport that to a system, store it, and that's the material that goes to the baghouse. In summary, that's a quick view of the total system, including the drying part, the milling operation, along with the combustion operation. Then finally, we add in a recycle loop just for further safety and for better operation. And as well, here we show that we also have natural gas coming into the system to make sure that we have, if we don't have enough energy in the sludge, we add natural gas to the system to maintain our proper temperature in the combustor.
Runway 21, runway 11 is available if you prefer advice, please. Autonomic Tower, this is 28 Zulu.
This is the velocity separator right below us from the Model 360 impact dryer mill, which is on the ground floor. The dried sludge and the hot air come up through this separator. The dried sludge and the gas come through here and go to the cyclone separator. Now, inside this cyclone separator, the dried sludge is separated from the gas. The dried sludge falls to the bottom of this separator and goes through the rotary valve right down there on the floor. From the rotary valve, the dried sludge goes to the Meteor dryer mill, gets dried one more time with drying air, and then from there it goes to the sludge combustor.
Transport fan to the burner. Temperature of the transport air, and there we can read the pressure. Transport air line.
What's that, about 300 degrees?
100 degrees.
That's the temperature of the transport air with the fuel in it going into the burner. Okay, what do you got here?
Okay, this here is the sludge input into the burner. Up in here, we have the secondary combustion air, ambient
screen shows all the current temperatures in the furnace, including the burner temperature, 2 thermocouples located one above each other in the furnace, baghouse inlet and outlet, and also the furnace draft pressure, currently negative 2.7 inches. Any number of trends, horizontal or vertical, or enunciator screens can be pulled up with the quick view option just demonstrated, instead of having to define which loop or which group that you want to call up. We can also call up the gas valve quickly to show how much gas we're currently using in the furnace. Currently we're at 55% throttle. We're just at set point, so it's still going up.
Okay, what we have here is the Williams no-knife hog, and if you would, please start it.
Clear?
Okay.
All right, if you would, let's get some of the cans up there. Don't put them in just yet. Hold on for it. Wait till I get up there. Okay, if you would. Okay, come down and show me the product, please. All right, are the pieces balled up or are they cut?
No, they're cut.
All right, thank you.
Now that's a 2-inch screen.
What size screen do you have in the mill?
2-inch openings.
2-inch opening knife hog. Can you change that screen?
To a 1-inch?
Yeah, any size you want, really, can't you?
Right.
Okay.
This is the 2-inch opening screen. We have a 1/2 inch. And this is the 1-inch.
And right now you have what size in there?
2-inch opening.
2-inch openings. So you have this screen right here.
Right.
Okay, it's April 28th, and today we're going to be running the Williams 2064 knife hog primary granulator. Feed material is 225 pounds of pre-crushed aluminum cans. These were high-density biscuits that went through a Williams number 52 wheel packer. That's going to be the feed for this machine. We have a 1 3/8 round hole screen. We're shooting for a density of about 15 to 18 pounds a cubic foot.
All right, Robert?
Ready, Robert?
Go.
Okay, go.
27, take off your tear weight, 17 pounds a cubic foot.
Okay, 17. Thank you. All right.
Okay, the Williams 2064 knife hog was equipped with a 1 3/8 round hole screen. This is the product from that test. And we're going to give you an idea of some of the sizes of the material. Here's a maximum length of about 2 inches by about 1 inch. Here's a piece of material that's about 1 inch square.
Would you hold some of it up so we can see, is it rolled up or is it cut?
As I sift through this, we're going to look at virtually individual cut pieces, individual layers of aluminum, no balling. Worst case is a double thickness of a can, which was already flattened before it entered the knife hog. There was some fugitive dust from the machine that was the dust that came in with the cans. However, very, very few fines were generated during this test. And again, it is a very flaky, uniform product that should be excellent for delacquering.
All right, thank you. All right, Ken, would you please tell me what you thought you saw?
Okay, we're running the knife hog with 125 horsepower, 900 RPM motor, full load amps of 163. Idle amps were 84. Peak under full load condition was 140 amps. It fluctuated between 125 and 140.
So your estimate of how much horsepower is required, please?
I would say 100.
All right, Carl?
This demonstration is going to be based on feeding whole automobile tires, steel belted radials, into the Williams 2064 knife hog, equipped with 125 horsepower and a 1 3/8 round hole perforated screen.
All right, Robert.
Product from the whole tires being fed to the machine. Other demonstrations were on aluminum cans. That's what you're seeing on the bottom of the pile here. 1 3/8 round hole screen has produced a product that is about 1 1/4 by 1 1/4 in this case, or as long as 2 inches by 1 inch, or 3/4 of an inch. A very uniform particle size, which would make an excellent tire-derived fuel for a kiln or for a power boiler. We have some liberation of the steel cord and bead wire, which could be removed magnetically.
Okay.
Okay, our next test on the Williams 2064 knife hog is going to be on scrap plastics, containers, PET bottles, milk jugs. Most of them in the 1 to 2 gallon container sizes, medium to light thickness.
What cage opening?
This will be through a 1 3/8 round hole screen in the knife hog. Just like that. Next, going to be feeding miscellaneous copper and aluminum coated cable and wire into the 2064 knife hog with a 1 3/8 round hole screen in an effort to chop the wire and remove, hopefully, the insulation.
In front of us we have one of St. Louis's busiest highways, Highway 40 in Ladue. And right there on the outskirts of this is the entrance to the section where the residents of Ladue have the right to bring in mixed brush or bagged leaves Monday through Friday, as shown here.
Where they take municipal brush and mulch and run it through the Williams 60KS hog, where it produces a fine mulch material for the residents of the community. The mulch is gathered by the various crews. They have several options of methods of feeding it to the hog. They can take their mulch, they can take their brush and put it through the chipper where it is direct chipped and thrown directly into the hopper of the 60KS. Goes through the mill and is air conveyed via the blast pan through the material handling fan and out the nozzle where it collects on the ground. This is some of the finished mulch material. It's a nice, fine, even product. They let this mulch age for a period of several weeks before they distribute it to the residents. This is a 200 horsepower motor, direct connected via coupling to the 60KS hog. It is running in a counterclockwise position.
All right.
Feed is controlled by a Williams Model E feed control panel. It is a fully automatic panel. Once the system is on, they can set their percentage of motor load set points, and the feeder panel will control the in-feed conveyor and vary it according to the horsepower demand of the motor of the 60KS.
So right now they've got the conveyor turning on and off at about 60%.
About 60%, that's right. Some of the cutoff logs that they put through the 60KS, they're a bit short for the chipper's grapple to handle and pull into the chipper. And these pieces they'll load on the conveyor and they'll go into the 60KS for shredding.
All right, Dave, would you show me what we're going to feed first?
First, we're going to start feeding some of this brush, which they've collected from the community, and their chipper will grab it with the grapple, and it is fed into the feeding mechanism of the chipper, blown out the nozzle and into the inlet of the hopper through this auxiliary opening to the hopper. you see some local landscaping contractors working for residents here at the city of Ladue, offloading some garden waste, brush, leaves, that type of thing. They'll offload it over there, and it will also be fed into the 60 KS to produce mulch for the residents.
Does it cost them anything to bring it in?
The mulch is provided free to the residents of the city of Ladue. The residents have the right to come and call the Superintendent of Public Works to request a load of mulch, and it will either be delivered or they can come and pick it up in their own vehicle. From the area where the discharge from the 60 KS, that mulch is then brought over to this staging area where it is allowed to sit and age for a period of time. This is the new mulch. It is not aged yet. And it sits here for a period of time until it darkens. And this is the mulch, finished mulch, that is then distributed to the residents free of charge.
How long does it have to sit before it ages?
I believe it has to sit for about 2 weeks so it won't burn the plants.
Nothing's added, just sits.
Nothing's added. This is just natural plant material from the whole city of Ladue.
Do they pick up free of charge on the streets now?
They also pick up free of charge. The residents bring their mulch to the curb site, and the Department of Public Works comes around and picks it up.
Okay, I'm now walking up a concrete ramp where the trucks can back up and can dump their leaves.
That's
All right, David?
The city of Ladue will pick up leaves from the residents, and their vacuum trucks pick up the leaves and dump them off in this site. And the raw leaves are staged in this row over there. They have a windrow machine right here that lifts the leaves, turns them, and moves them into these rows where they're aged. And
what about the bags?
The bags, they have public department works people that tear the bags open and dump the leaves out, and then they discard the plastic.
Okay, so the plastic is not in there.
The plastic is not in there. They take the plastic out. They just want the leaf mulch.
And now the leaves are in here.
The leaves are turned, and they are wetted so that the biologic activity will start the breakdown of the leaf. They also add some urea, and they take the temperature of the leaf mulch to make sure that they keep it turned at the optimum times to speed the breakdown of the leaf material.
Is this also made available to the residents?
This is also made available to the residents free of charge. So the residents have their choice of leaf mulch or wood mulch.
Okay, if you would start it, please.
feed material that you're looking at has been shredded in a Williams 150 horsepower 34 by 56 grip shear shredder located at Tire Shredders Unlimited in High Ridge, Missouri. They're processing whole automobile tires at a rate of about 800 tires per hour. And we're producing various sizes of strips ranging from 2 to 4 inches wide to 12 or 14 inches long.
Okay, what does that weigh?
The first drum that you're looking at here weighs 120 pounds.
Okay, and we're going to run approximately 4 of these into this knife hog. You want to point it out? Tell me something about it.
Okay, this is the Williams 2064 knife hog powered with 125 horsepower. We're going to be operating at approximately 185 RPM. The screen size, the bottom of the unit, is 1 3/8 inches in diameter.
Can you show me a typical screen?
Various screen sizes that are available. This is a 1-inch screen size, which will produce a nominal 1-inch chip. And up here we're looking at approximately 2-inch size chip. Various sizes are available all the way down to 1/2 inch in diameter, depending on the degree of reduction required. We weighed up these 4 drums, and our gross weight is 528 pounds.
Okay.
Monitoring the amp meter on the machine to determine our optimum feed rate.
All right, thank you. Let's load them up. Throw it on, please. All clear. Okay, go ahead.
Looking at here is the product from the 2064 knife hog using a 1 3/8 round hole screen. Chips appear to be 1 inch by maybe 1 1/4 inches. maximum. Some liberation of wire with some rubber that's still hanging on to the wire, which is separated cord and rubber. We're going to get a bulk density on it shortly, but the product size is definitely nominal minus 1 inch.
Thank you.